Now when we take the indefinite integral of a function, we're finding a general solution of an integral. So if you were finding the integral of x squared with respect to x, that would be x cubed over 3 plus c. To find a particular solution, what we're looking for is the exact integral where we find c. Okay? So all you need to know is the value of y equals f of x for one value of x, and that will be enough to be able to find out what c is. And this information is what we call an initial condition. So for example, I want to find the particular solution of y equals x squared dx, the integral of x squared dx with the initial condition that f of 3 is equal to 15. So y is going to be the integral of x squared dx, which we know is x cubed over 3 plus c. This is my general solution. Okay. And to find c, I'm going to actually let this y be capital F of x. And if I know that f of 3 is equal to 15, then this means that 15 is equal to 3 cubed over 3 plus c, or 15 equals 9 plus c, and if I subtract the 9, I get that 6 is equal to c. So that tells me that I can just plug that in, and my particular solution for these conditions is f prime of x. You can either use f of x or you can use y, it doesn't really matter. Y is equal to x cubed over 3 plus 6, and that would be my answer. So with this one, I would have, let's see, y or f of x, if you want to look at f of x, is going to be the integral of f prime of x with respect to x, which is the integral of 1 over x squared with respect to x, which is the integral of x to the negative 2 with respect to x, which is x to the negative 2 plus 1 over negative 2 plus 1 plus c, or this gives me negative 1 over x plus c. So I've been told that f of 1 is equal to 0. So that means that f of 1, which is negative 1 over 1 plus c, equals 0. So I get negative 1 plus c equals 0, and if I add 1, I get c equals 1. So that means my particular solution is capital F of x equals negative 1 over x plus 1. Now in this problem, we are trying to find the general solution of f double prime of x equals x, and the particular solution that satisfies the conditions f of 1 equals 1 and f prime of 1 equals 2. So since a second derivative is really just where you took the derivative twice, in order to do this, we're going to have to take the integral twice. So I'm going to start by finding f prime of x, which is the integral of f double prime of x. Okay, so that's the integral of x, which is x squared over 2 plus c. And I'm going to call this c sub 1 because we're only doing the first integral here. So to find c sub 1, I'm going to use the fact that f prime of 1 is equal to 2. So this means that 1 squared over 2 plus c sub 1 is equal to 2. So 1/2 plus c sub 1 equals 2. So that means c sub 1 equals 1.5 or 3/2. So that tells me that f prime of x is equal to x squared over 2 plus 3/2. So when I go to find f of x, this is going to be the integral of f prime of x with respect to x, or the integral of x squared over 2 plus 3/2 with respect to x. So splitting this up, I would have 1/2 times the integral of x squared with respect to x plus the integral of the constant 3/2. So this would be 1/2 x cubed over 3 plus 3/2 x plus a c sub 2. So this is going to be 1/6 x cubed plus 3/2 x plus c sub 2. And then I need to find c sub 2. And I'm going to use the other piece of information that I had, that f of 1 is equal to 1. So f of 1 is equal to 1, so that means that 1/6 times 1 cubed plus 3/2 times 1 plus c sub 2 is equal to 1. So that tells me 1/6 plus 3/2 plus c2 is equal to 1. If I find a common denominator here, I get that 5/3 plus c sub 2 is equal to 1. And if I subtract the 5/3, I get that c sub 2 is negative 2/3. So that tells me that my final function is 1/6x cubed plus 3/2 x minus 2/3. And that would be my answer.